No, we need a dilation too. Okay, so we need a dilation. Number 2 is asking us, can you come up with a sequence, meaning a series of steps of a translation, rotation, reflection with a dilation that would move ABC onto DEF? What do you think now? So turn and talk with your partner. What do you think? What would the series of steps be? Should we rotate it first? Should we move it first? Should we dilate it first? Turn and talk to your partner, please. So then we'll have a shift or a translation of right 6 and down 4. Okay, again, this is stuff from Unit 7, transformations. It's going to come up again. We are approaching a final in about 11 days, okay? So it's going to come up again. Cool? What's the relationship between the pre-image and the image of the transformation? What's the relationship? Are they congruent figures? Are they the same? No. And this is what we're getting at today. So we're going to say they're not congruent, right? Congruent figures would have equal sides and equal angles. They're not congruent. What do you think about the angles? Did the angles change?
No.
So let's write that. The angles are the same. And we'll see how that helps us here. Number 4. Do you see what else came back again? This is all great review for your final exam. Look what else came back up. The distance formula. It's been a few units since we talked about distance formula. But now we're going to use it to classify the triangle. Classify triangles. All this stuff that we learned earlier this year. Let's look at 4 together. Let's do it together. It says, determine all 3 sides of both the triangles. Label them in the picture. You can just put them right in the table. What patterns do we see? Can we classify this triangle? All right. AB. Let's not overcomplicate this. How long is AB? 2 units. So in your table, will you write 2? And we just did that by counting. Because we can. We didn't have to use the distance formula, right? Use the graph if you can. Look at DE. On the smaller triangle, how long is DE?
1 unit.
1 unit. All right. We didn't have to use distance formula for those. Let's not overcomplicate it. All right. AC, I'm going to have to use the distance formula. I'm going to go up to the graph because I know we like to use triangles here, or slope triangles. So we went right 1 and up 1, 2, 3, 4. 1, 2, 3, 4. Right? Think about it like this. It's a right triangle. It's Pythag theorem, right? This is where distance formula comes from. Remember that? All these things that are going to be on your final exam. I know. So we really have 1 squared for our x, right? We just figured this out by looking at the graph. 1 squared plus 4 squared, all under the square root. So let's add that in. We've got, this is 2. This is really going to be 1 squared plus 4 squared, all under our square root. Okay. What's 4 squared? What's 1 squared? Okay. Add them together. Under the square root is going to be what? 1 plus 16 is going to be 17. Let's look at BC. Look at BC. Let's use our Pythag theorem again, our distance formula. It went right 1 and up 1, 2, 3, 4. That's really similar. That's really similar. What do you predict AC is going to be? How long is AC going to be? The square root of 17. So far we've got 2. We figured this out. It's 1 squared plus 4 squared. We also just saw that this has the same side length. I have a triangle with 2 sides that are the same. What kind of triangle is this? Uh-oh. Isosceles. An isosceles triangle. We know that this is 1. If we go to this image, I want you to figure out DF and EF right now with your partner. A clue for you is they should be the same, right? We've got a similar figure here to ABC. Try to figure out DF and EF with your partner. We still have another isosceles triangle, but it's just been shrunk. Right now with your partner, I want you to figure out the angle measures. Again, good review for our final exam. If you know this is an isosceles triangle, they told us one angle. Can you figure out the other 2 angles? Turn and talk with your partner. Go. Turn and talk. The measure of angle A is 76. What's the measure of angle B? What's the measure of angle C? All good review. Your final exam's coming up soon. B. Why? I love it. The 2 base angles in an isosceles triangle are congruent. Perfect. So then what did you get for the measure of angle C? 28 degrees. Because... perfect, right? The angles in a triangle add up to 180. Can't forget that. Sweet. Questions on our little activity. We saw similar figures. Are you ready to define it? Okay, flip the page. Similar figures. We just proved 2 figures were similar. How did we prove it? First, we identified that there was a sequence of transformations. And then we found that the corresponding sides and angles were similar. Let's do it. There's 2 ways to prove similarity. 2 ways to prove similarity. The first way is to prove that there is a series of similarity transformations. In case you forgot, transformations are reflections, rotations, and translations. Dilations. So we did that at first. We saw that there's a way to transform it from one to the other. We should make a special note about dilations. We make a special note about dilations. When you dilate something, it's always going to produce similar figures. Figures or shapes. Cool. You ready for method 2? Method 2, which we're going to practice in the check for understanding together. Method 2 is you need to prove each set of corresponding sides is proportional. That's a word we used yesterday. And that the corresponding angles are congruent. So we need to prove that each set of corresponding sides is proportional. That's a word we defined yesterday. And corresponding angles are congruent. What does congruent mean again? Equal. One more thing. One more. When I use similarity, the symbol that means two figures are similar is this little squiggle. Do you see it? I'm going to write it in another color. This squiggle means figures are similar. So for our first problem today, we proved that triangle ABC is similar to triangle DEF. That's what we did in our little activity. The little squiggle means similar. Okay. Do we see that X corresponds to 7? Do we see that? So I'm going to say X over 7 equals... I got to pick another set of sides that are corresponding. Which side? Which ones do you want to pick?
36 and 4.
36 and 4? Which one should go on top of the fraction?
32.
Good, because X was on top first. And now, what were we going to do?
Divide.
We could divide. We could cross multiply. Let's do it. Let's solve for X now. That's what we did yesterday. Remember yesterday? You could also divide. Get your calculators out. What'd you get for X? Which side length? What? Perfect, 63. If that side length was 63, then all the corresponding sides would be proportional. Cool. So again, we have to prove that things are proportional. Questions? I want you to try number 2. It says, is triangle dog similar to triangle cat? Explain why or why not. I'll give you a hint. You should be looking at the proportional relationships. Are all the sides proportional? Ready, set, go. Try it. Similarity ratio. Did we get the same similarity ratio? No. None of these are equal. Explain why or why not? No. It's not proportional. If it was proportional, we would have gotten the same similarity ratio for all 3 corresponding sets. Whoa, we covered a lot of vocab there. Corresponding, proportional, similarity. We did a lot. We also reviewed a lot. Isosceles triangles, distance formula, transformations. How do we feel? We're all a little tired. It's okay. Here's our homework. I shortened the homework for us. We're only going to do, in your packet, 2, 3, 4, 5, and 9. Now be careful. I think in our homework packet it printed 2 pages. You're doing the first page. There's a second page. You're not. Sorry. In your packet, there's like the first homework assignment is 8.2, and then there's a second homework assignment that also says 8.2. You're doing the first one. Okay? I'll put it on the screen too.